Hey there, everybody. Welcome to another episode of the Ruby Rogues podcast. I'm the host today, Valentino Stoll, and I'm joined with a co-host, Luke Stutters.
Hello.
And we have a very special guest with us today, Sankha. Do you want to pronounce your last name for me?
It's Sankha Guria.
Sankha Guria. Welcome. Why don't you introduce yourself and tell us a little bit about what brought you on our show today?
Hi, so I'm a PhD student at the University of Maryland doing programming languages research. So today I'm on the show for one of the research projects that I have been working on called RBSyn, which is a program synthesis tool for Ruby code. So you write in the types and you give a bunch of tests, and then my tool comes with the correct code that passes all those tests. So I'll be chatting about that today.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv. And I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So for those who aren't familiar, like myself wasn't before I kind of dug into your library here, what exactly is program synthesis?
So program synthesis goes to this very old idea in computer science. Like if we can specify some behavior for the program, then the computer should be able to come up with the program itself. And of course, this is a very hard problem. And so it has always been a holy grail of AI. But what recent research has shown is for very specific kinds of programs, you can have domain specific insights that can actually help navigate the tedious code writing part and then give you a correct program automatically. And there has been a lot of success stories as well. Let's say the flash fill feature in Excel, whereas my tool sort of tries to explore this in the domain of writing Ruby on Rails applications, where you have database model methods and so on. So can we automate those kind of tedious model methods?
Yeah, I mean, I could see why, it's an area of interest for quite a lot of people. It seems like it would be a holy grail kind of situation if we can have computers program themselves. So what got you interested in this to begin with? What made you pursue this particular aspect of your CS PhD?
So I joined the PhD program thinking I would at that time I was interested in type systems. So back then a lot of interesting thing was happening in type systems like TypeScript, which was the type system for JavaScript, and it was gaining traction. So I was let me explore what happens for Ruby, because I was at a job which was where I was writing a Ruby code a lot of the times. And then I found my advisor, Jeff Foster. He has been doing a lot of research in Ruby type systems. And so I joined his group. I started working on the Ruby type system project called RDL. Now, we wrote some papers on that, and then the system still works. But then what happened was Ruby 3 decided to adopt types. So that was a big win for us. So all the research that was going on sort of got adopted into the mainstream, and Stripe had a big they created a big team that sort of started writing their own type system called Sorbet, and that is an industrial grade type checker. And there's no way we a bunch of grad students can match up with that sort of effort. So what we did was I started thinking about what are next things that I could think of. And so I decided to go to the other end of more experimental stuff. So I started looking into more experimental stuff, can we synthesize programs given some tests and types, because that's test is something Ruby programmers usually write. So might as well use that and automate some part of the programming burden.
And I must add, this is, if anyone's listening to this and they hate types like me, I mean, most Ruby programmers can't stand types. We've got in Ruby to get rid of types. This put me off a bit at first because it looks very typey, but it's not really about types. The types here are merely a means to an end. And I'd like to go into the what you talk about. I think you talk about a kind of type search and isn't an effects search, but the types here are merely a way to do some seriously cool stuff. And as Valentino said, this is kind of, the computer's doing the work for you here. And really the code that comes out is pretty good. I mean, it's not outrageous. There's some bits in there that I don't quite get, but it really is, given a test or a series of tests, it will write the code for those tests. It does work.
Yeah, so I know I have also been put off by types when writing in a dynamically typed language. So types are sort of something that people look down upon in this JavaScript Ruby space. And I started appreciating types when I realized I don't need to test every branch of my code, and I could just put a type annotation and I could catch those silly bugs that let's say I'm expecting an integer and then I sort of return a string. That's an obvious thing. And let's say if my program has 10 if then else statements, I need to write 10 tests. That's something that I did not need to do after adding types. And a lot of design has gone into ensuring that you only write the types for the things that you really need. And it's not like Java, you don't need to put types everywhere. So you can opt into types in some places and opt out of the places that you don't care about. But for the aspect of synthesis, what types give you is some sort of way to structure the code space. So something that, yeah.
Yeah, this was really interesting to kind of see your example here. I really liked kind of the RSpec syntax that you have for it, where you define kind of, just in your top example, you're defining a method with, the arguments that it can take, expressing the types in kind of a string format, and then just spec by spec blocking off what assertions that you want the code branches to look like. And it's kind of interesting to look at the code in that way too. I don't know what your thoughts are, Luke, on kind of the nature of the specs themselves, but you're right, Sankha, we're making tests anyway. Maybe not Luke, but the rest of us are making tests anyway. And if we can make maybe this is a bit contrived example that you have of a more slim version as is kind of the initial wave of your research, but there are so many, if we think about in a Rails application, you want to create some CRUD interface, right? That's pretty basic line of commands and views to update to get that together. And it seems like something that would be perfect for synthesis, where you can have those base examples generated pretty easily, right? Instead of the 10-minute blog post video, it could just be, a 5-minute spec creation that then generates the whole application. I could definitely see that. So I'm curious, what kind of barriers, what are your biggest hurdles kind of with the synthesis?
So the biggest problem with synthesis is the number of programs that can actually pass your test cases. I give you a test and then you give it to 100 people. 100 people will come up with 100 different versions of the same program, and all of them are correct. So really, you need some sort of way to search efficiently, and you need to come up with some correct solution. So we encode a bunch of heuristics. I think the most obvious here is we are looking for the smallest program that passes the tests. And then the way types and effects are sort of set up is it helps us to navigate the set of programs possible in a structured way. So we know, let's say a database will have this column, so we only access that column in that particular table. We don't really go off and start looking for column foo or bar, which doesn't exist in the table in the database table in the first place. So, and type system helps us encode that. And then our effect, so we kind of designed an effect system from scratch for this. I don't think we have discussed effect systems at length, but I can discuss them for 2 minutes before I give an.
I would like to jump in just quickly and talk about the effect system. So, my understanding is one of the big things this can do which stuff like flash fill can't, is that flash fill and most conventional, what do you call it, program synthesis, auto code writing systems, they're kind of based off functional languages, and functional languages don't really do state. Whereas, of course, Ruby on Rails is all about cramming the most state into the least lines of code. So one of the really new things about this work is that it explicitly says, right, we are going to handle stuff that changes databases and makes persistent changes, and we are going to develop a system that can write code to make those changes. And I think you referred to it as a kind of, was it the effect system?
Yeah, exactly. So as Luke mentioned, so in this flash fill sort of world, what you have is you have a function where you have a bunch of inputs, and then the only way the output of the function changes is the input changes. If the inputs remain the same, the function always computes the same output. And that's sort of the benefit of being in this functional world. But in Ruby on Rails, we know, even if you have the same arguments with the function, we the database state changes, and then, our functions will compute something else. Or let's say we are writing to the database, and depending on the current state of the database, even though the arguments remain same, the things will be things written to the database will be different. So what we decided to do was call these effects. Effects means something that changes the state of the world. And how do you do that? These are things that do not show up in the return value, but they are sort of expressed as other things that happen, sort of like reading to a file or writing to a file, reading from a database or writing to a database, throwing exceptions, catching exceptions, and these sort of things. So we kind of design these abstract level things that sort of allow us to keep track of what kind of read or writes are happening, and then allows that for synthesis.
So my understanding of how it works is very limited, but there are a couple of diagrams which describe this kind of tree branching effect, where I think what's happening is your program synthesis function is just iterating through each possible thing that it could do and saying, well, does this work, does this not? And as it goes along, it eventually reaches a dead end. And at this point, you stop looking at just the types and whether the types are correct, and you start to go and look at the kind of database changes separately, correct? And then you kind of iterate over those. But then, which is the kind of really clever bit, is that they merge the two together. And this is the bit I didn't understand at all, but somehow you take this kind of these two possibilities, is it just to return the right type, and this other set of things where does this make the correct database changes, and stitches those together, and what you get out is just a kind of if statement, really. You just get branching logic. But I could not wrap my hand around how this is happening. You said in your paper that it was novel. Does this mean you've come up with it yourself?
Yes, that bit is indeed novel. So what ends up happening is, so imagine how you'd write RSpec or a mini test. You do some stuff in your program, and then at the end, what you do is assert on a bunch of things, right? And those assertions, what you do is you assert on, let's say, the value that has been returned by your method, or you assert on some global state or some value in the database and so on, right? And here's the two things. If it's a value returned by your method, types guided search will find it, because types sort of are good at reasoning about the things that your function computes, because that's what type checking does, right? It checks if your function is returning the right thing.
Yeah.
And what effects will do is, so let's say my tool comes up with a candidate, it will run against the test, and then what will happen is it will fail on some line that says assertion failure because some database column failed to match. And from there, it's very easy to infer, okay, maybe the database column did not have the right value because I did not write to the database column in the first place. So this is where the magical inference bit happens. Okay, from this assertion failure, I know that this database writing did not happen. So I'll go ahead and refine my function so that I put in this writing call in my function. And this sort of back and forth feedback loop continues until you have a candidate that passes one of the specs. And then once you have a bunch of code that passes each of the specs, we sort of put them together with, let's say, the conditions in the if then else. And then, yeah.
When it's doing this search, when it's going through these functions, when it's trying things, trying this, trying that, obviously that's, there's a whole lot of possibilities. Is it just rolling the dice? Is it going through each possible method call in sequence, or are you using, I don't know, a kind of machine learning method or heuristic to kind of make it guess the correct one faster?
So right now it's trying everything, but it's still pruning the search space because of the types. So for example, let's say you want to access the database, so you want to do something like active records update method. So you're not looking for, let's say, the integers plus method, right? So it will not try that. And this is where types come in. Types are sort of narrowing down the search space because you'll have much more incorrect methods than the set of possible methods that you could use. So if you know that you are willing to look right to the database, you are not looking for something that adds two numbers, because like integers are unrelated to, let's say, the database type that your active record is using. And so what happens is, because of this type guided search, like around 90% of methods just are discarded right off the bat, and each step wherever we need like the whatever values, we look up the types for that values and then only use the methods that will produce values of that type, which is why like it's still good in performance without using any machine learning. But that said, I would like to plug here that there can be a lot of interesting future work which could use machine learning to sort of guide this search instead of like brute forcing through the all possible set argument.
Yeah, I'm looking through the code here on your RBSyn, and you have kind of like a component structure to active record, and this active record, I guess, component is pretty small. It's a lot smaller than I was expecting. But it's interesting to see how all those types work and how you're wrapping kind of the things that you can do with active record. And I can definitely see applying kind of maybe the Rails documentation site or something like that to generate these automatically. So I'll be interesting, what kind of other components have you played with or maybe thinking about trying out next to see what else is possible, or maybe narrow the scope on what you're focusing on?
So for this piece of work, what we did was we looked at some set of methods that are used by production applications. So like GitLab, Discourse, all these apps. So I actually went down and looked at the tests that the developers of these applications had written and looked at what methods they were using. So the subset of the methods that you see were the methods that they use. So I like wrote the annotations for that. And luckily, like this subset was good enough for us to synthesize like the set of benchmarks that we are looking for. But that said, another example would be, so this is actually another benchmark. So I think this is GitLab. So GitLab has this gem that they use to manage a state machine. So this is used for their issues page. So issue can be in open state, closed state, reopen state, and this is managed through a state machine. And they like use the state machine gem and then have a bunch of tests to check, like, as each of the functions are called, it ends up in the correct state or not. Now, this is something interesting that happened. I did not include the gem at all. I just feeded the tests as is, and it came out with the correct code by just manipulating the database entries. And the gem was not needed. And the code was correct because it passed all the tests. So, yeah, that's the interesting bit, right? Like, it can come up with correct tests, correct programs where you don't even need the dependencies outright.
Wow, that's pretty interesting. So there's quite a few benchmarks you have in here. It's really neat. So where do you take this next? Like, what's so you've gone and you've benchmarked quite a few popular gems or popular source codes that you wanted to target for this. What's kind of the next step in the synthesis project for you? Where does the paper lead?
So I mean, there are few next future work that I'm sort of exploring. One is I just use types here, but you could think of very abstract properties that you can think of. Let's say you can say my string length should be between this range, and the tool should be able to like, okay, I know that the string length should be less than 5, and I should be able to reason about everything else from there. So I'm starting to think about some more vague properties like that you can just imagine. So I like to think of this as something that, let's say I'm pair programming with someone, and let's print this out. Okay, this field is not true for this object, so something is wrong. Let's debug that. So these kind of properties that we care about when debugging, these sort of properties can automatically be picked up and then used for synthesis. So that's sort of the avenue that I'm going for. And other than that, like there's a bunch of more things like this. Right now, RBSyn does not support metaprogramming, which is like a big thing in Ruby. So that's currently an open problem. I have no idea how to get that to work, but yeah, I'll probably have to spend a lot of time thinking about that.
It's the Pandora's box of programming.
Yeah.
So I'm curious because there are kind of a few different pathways for code generation, right? That we've seen where GitHub has their Copilot or whatever they call it is a Copilot, I think. Where there's kind of like assistive code generation where it's based a lot on the context and the things that they have available. Or there's like the code assistant Kite, I believe, right? But this is taking kind of like a a different approach, right? Where you want to create, your test cases in advance. And it reminds me a lot of just like the Cucumber era, right? Of the Gherkin processor.
The BDDs.
The BDDs. How are you thinking about pursuing that kind of mentality going forward? Is that kind of where you see it taking off, is kind of revisiting that BDD kind of code creation?
I sort of think of this as more of a conversation with so right now it does feel like a BDD based approach because you write the tests up front, but like with more UX effort into this, what I would imagine this to look like is something like you write one test case or you write part of the program, and then like as you write more test cases, the tool can automatically come and fill in the program that you would have written, and then you can. So this is the main difference with Copilot or Kite. Copilot, you need to spend some amount of your mental energy reviewing the code that the tool generates. Whereas with this, if the tool generates something, you can be sure that the tests are getting passed by the generated code. So that's like a good guarantee to have. And so let's say you come up with a new test case, the tool will update the code. Let's say you are not happy with the code, okay, I missed some test case. So either you go and update the code yourself, or you can write another test case that you probably missed. It's more of like conversation with the computer, where the computer is assisting you writing the code.
Hey, folks, I'm here with JD from Raygun. JD, I mean, it seems like a lot of things these days are kind of pushing us more toward productivity, right? We install VS Code extensions, we do CI/CD, we kind of get this stuff off our plate, automate as much as we can, and move quickly. And one of the tools that I tell people to get is something like Raygun. Do you want to just explain real quick how Raygun can help with the productivity?
Yeah, absolutely. I mean, it's several-fold. I like to think of Raygun as almost being like a full-time engineer on your team that's keeping an eye on things and is able to report the important faults or performance bottlenecks so that you aren't guessing. And so that's one element. But then to that point where we store is all of the data we possibly can on the context of the error or performance issue, so that we integrate with source control systems. You can jump into our APM and get method level timing details with the source code right beside it. So if you're looking at it going, why is this page so slow? You can usually just eyeball the code right there and then. So speeding everything up, which I think is really important with, our industry is under so much pressure right now.
Yeah.
We've got to try and get people being more efficient because we're not going to have a whole lot more people suddenly.
Right, absolutely. And I love that idea. I've done plenty of optimizations myself, right? And having an APM tool that will actually say, this is the slow code, right? So instead of me trying to guess or look at it and go, oh, do I have an N+1 query here? Yeah, it just tells me where the problem is. And that's really powerful in something like Raygun or...
Yeah, absolutely. I'm a huge fan of Iron Man. And, the idea is that I would love a virtual Jarvis that's just going, hey, there's this thing. Do you want me to go fix this? Do you want me to solve that? It's like, that's what we need to get to.
Yep, absolutely. Well, if you want the next best thing, go to raygun.com. It's not Jarvis, but it will tell you where the problem is so you can go fix it. You can get a free trial right now if you want. It's raygun.com.
I've got a question about the it's called RB SYN sign, which is the synthesis, right? But it says on the paper that it's based on a thing called lambda SYN or lambda. I want to call it sign. I'm so English, sorry. The lambda sign. What is lambda sign?
Yeah. So lambda SYN is, so in the paper, what we do is, since Ruby is a very complicated language and showing all those mathematical rules, like all the inference rules for real Ruby is a very big challenging task. So what we do is we sort of take the core essence of Ruby, put this in this nice mathematical language that we call lambda SYN and show that, our idea works in this core language. Now we take this idea and apply it to a real language called Ruby. And so that's what the tool RBSYN is. But if someone wants to take away the core theoretical essence of how the thing works, they should care about lambda sim, not like the entire Ruby, because Ruby is much more complicated.
Was part of the reason you did it in Ruby because if you can generate Ruby code, you can generate any language because there aren't too many languages where you can do the stuff that you can do in Ruby.
Yeah. So for example, I mean, part of that, actually, most of it is correct, to be honest. Like branches and any other method call, like that sort of thing is sort of working right now. What will not work right now is what I'm working on that at the moment, which is lambda functions. So Ruby procs or lambdas. So that will not work right now with RB whatever is released. So that will not work, as metaprogramming will not work. I said this before. So what else? So loops, lambdas, these will not work. Yeah, I think that's primarily the things that like are not supported by RBSyn at this moment. Everything else that I can think of works, like hashes, lists work well.
So I've got a question about where it doesn't work. So on your paper, you talk about this combined approach of using both the type checking and the effect checking means that you can synthesize a lot more code than you could before. But obviously it can't synthesize every test. And this kind of jumped out at me. And I thought, oh, this looks like it could become some kind of, if not a code quality, then a test quality metric. So you could kind of use this to measure how good and how kind of useful your tests in your program are. Is that something you've looked at, or a possibility?
So this is something that actually popped up when we were checking our benchmarks. So what happened was we took the tests as is from like the big projects like Diaspora or Discourse, and what we did was we ran them through our tool, and then our tool popped out, like gave us some output, and then we cross-checked that with the actual implementation that the engineers for those projects wrote. And in few cases, what we found is the code synthesized by our tool is not equivalent to the code that the programmer for that project wrote, which means the tests are not doing a good job of testing the code that they wrote. So clearly this is an anecdotal observation, but like I don't want to make a general comment based on that. But this has been my experience when writing tests as well. Like I do this all the time for my code, that my tests sort of check some parts of the code, not everything. So yeah, so sort of this gives you an idea, like this tool could be used for checking, okay, are my tests sufficient for the function that I'm testing, or am I running short of the test that I have? Should I add more tests for certain cases that I'm not checking?
So one of the things you can do in the RBT is you can kind of say, well, this method could take an integer or a string or some other type. And I think you call this, is it union or intersectional types?
Union types, yeah.
How much of an effect does that have on the program synthesis when you have a function that can allow a lot more different kinds of things?
So it depends on where it's used, to be honest. Like, let's say if some function argument can be both string or integers, that means you have to check all possible methods that can be used. So you have to try all the methods from strings and all the methods from integers, which sort of doubles the number of methods that my tool needs to run through before it comes up with the correct candidate. But if it's something in the return value, then like this needs to be in the intersection of so let's say only methods that are common between integers and strings, only those are expected, because if something is expected to return an integer or string, that means any downstream code will only operate with this assumption that it's in this intersection of the all possible methods between these two types.
And my follow-on question from that is that imagine that you've kind of done all the meta programming, but you've kind of got all the lambda functions, you've implemented everything you possibly can in the Ruby language or any other language. Is there a category of method, a kind of some kind of code that can't be generated by this method? Are there kind of certain things where program synthesis can't theoretically work?
So this is like a very high level observation that I had. Program synthesis is only useful when specifications, in this case the tests, your writing is sort of worth it. And you should not be repeating the exact function that you are writing in your own specifications, right? Because then you could have written the function directly. So that's why, like, there has to be this space of you want the synthesis tool to be useful enough such that you can get away with writing very light specifications. So the moment you want like a very complex function that requires a bunch of, like, you're almost writing the essence of the function in the tests, then I don't see a value proposition in synthesis, to be honest. And the second thing is, so in theory this works out, but in practice what happens is combinatorial explosion takes place. So like, let's say you have a function that's probably, let's say, 15 lines long or 100 lines long. What happens is rbsim sort of tries to nest function call inside each other, and so it's like a nested chain of functions. What happens is it tries a bunch of functions, and the space of programs that it explored just increases exponentially, which means it takes like a long time before you can reach the solutions. And in such cases, we have to terminate the search without getting any solution. So we definitely need a better way to guide through this search space of programs if you're doing like long functions. And maybe machine learning might help there, but currently there's no good solutions explored.
I have a question about how you've thought about the evolution of these specs. Are you thinking about it? So as let's say that people start adopting program synthesis in their workflow, how do changes work? How does that process work? Like when you make changes to these specs, does that regenerate the code basically?
Yeah.
And so you don't have to worry about it, whatever it makes, because it's just something new?
So that's sort of my impression. So like different researchers have different ideas of what the future would look like. So something that I sort of want to have, the future that I am striving for, is something like you have a bunch of specs that you have, and the specs can automatically generate a function implementation, and that's all great if it works out. And then you can just take that code and run it. Let's say you update the spec, and the tool will update the code accordingly. But something more practical is something like this. So let's say the substring function. All of us have used substring before, and it's a tedious, painstaking process to think about the start index and the end index. And we always tend to make this off by one errors because like something or the other goes wrong, and we have to like check and go back. And I think these are the specific cases where like something like program synthesis will help. So something like you're writing a big function and you leave some holes in there. Let's say you want to take a substring of some big string, and you don't know the indexes of those. So you just leave some holes, which are like, let's say, question mark underscore, which are like a special method call. And you have the specs, which give you the correctness conditions of the code. And from that, the tool comes in and like, okay, so these holes will have these integers, also like say these operations on the variables to come up with the correct indices for the substring. And so I sort of see this as taking the burden off the programmer so that they can focus on the high level business logic and not care about those tiny tedious details that always pull us down, and take out the pen and paper and solve for those, which should be taken care of by the computer.
That makes sense. Yeah, I mean, I did have another thought on kind of the benchmarking, because as you say, depending on the test case, there could be many different ways, right, to generate the code. Are you investigating maybe doing micro benchmarks on those various options of code to optimize what would be the most performant or resource, sensitive method to use over the other? Is that included as part of the, synthesis, or is it kind of just like a first match basis?
It's right now a first match basis, but that's an interesting idea, which I have not tried, but like come up with a code that sort of is more optimal for this operational constraint. I mean, that would be, I can see that being useful, but that's something I have not tried.
Yeah, I just think of the fast Ruby, where they have a bunch of Ruby idioms where you can iterate over an array. It would be an interesting experiment to run through, the synthesis on those and see if it can generate, based on whatever is more performant. So what's your next step? Do you want to work on program synthesis forever, or do you have, other future plans that you'd like to explore?
I mean, I do enjoy working on program synthesis. So, but I would like to explore like more. So right now I'm exploring like the key approaches to doing program synthesis, but I would maybe sometime in future, I would like to explore what are the domains that I could apply them to so that it's useful to end users. So that's something I'm looking forward to exploring.
I'm not really scared by flash fill. There's no way flash fill is going to take my job, but this kind of looks like, I mean, you have to kind of use your imagination a bit, right? But I don't know about you, Valentino, but I look at this and I think, are we heading towards a dark and terrible future where programmers, software engineers just spend all their time writing kind of specs or tests? I mean, I can kind of see it coming at me now. Am I being realistic about this?
I mean, I have had this conversation multiple times before because this is like the first reaction that people have. Is this gonna be the future? But to be honest, I think programmers have this one job that it's very hard to replicate. You have this vague business problem that you're willing to solve, and programmers are those kind of people who like translate that vague problem into very strict, specified, constrained problem that actually translate to producing value. And that's where the human insight comes in. And I don't see any way machines can take over doing that yet. So because like think about like the let's try this thing, and that's a very high level idea, but like how do you integrate those components together? That's the very highly specified thing that programmers do. And I think what tools like these will do is it will allow us to focus on the more high level interesting parts of the problem and take away the boring parts of the job. Because I mean, I don't see how programmers were adding value there anyway, because much of our insight were going to the high level parts of the system anyway.
That just sounds like harder work to me. Give me a nice, simple, straightforward controller any day.
You know, I like to think of it in the analogy of Scratch. Are you familiar with the MIT Scratch software?
Is that the visual one?
Yeah. So, I mean, it's what's used for kids to learn how to program, right? Where you have a bunch of blocks and you drag them around and set up your own branch scenarios. And, that's kind of where this leads, right? Where you kind of you take out all of the granular details of how that comes together and how it assembles, right? Like, Aaron Patterson jokes like, let him, write assembly so you don't have to, right? In a similar way, Scratch does all of the programming so the kids don't have to. And, it does constrain what you can create with it, right? Because it only knows what it has the options to do. But I think the possibilities are definitely large enough, right? That it allows for creativity, right? Like if you've seen anything one of these kids that has used Scratch makes, it's kind of interesting, and it's always unique. And I think that this could kind of lead that way. And I feel like programs even that would write themselves, which there are those that do that, right? If you think about Google started their API generation tools, a long time ago. And they do that for various languages and generate their APIs for that based on their schemas that they have for their APIs, right? And so there are already tools that do this and program themselves. And like Sankha said, it just makes it less grueling, right? Like nobody wants to have to recreate the same API in a different language or regenerate the documentation for it, right? Like those are tools that nobody has to do. Right, like nobody should have to do that, and
yeah,
I'm looking forward to that day where I don't have to port some library to something else.
Yeah, that's definitely the future that I would want to live in. Like, let me write the interesting code, let the computer take care of the boring bits.
I'm going to ask another question here, which I'm sure is one you've heard before, but it's something that's at the forefront of my mind. Is there any way at all this could work without types?
So this can work without types. What you need to do is just assume that instead of types, everything goes from object to object. And what you're doing is just you're not narrowing the search space anymore, but you're just like in a dynamically typed language, you're like trying all possible methods in the universe that you have available to you and trying to construct programs from there, which is fine if you have a lot of CPU power to burn, but types here really help narrow the search space. But I could imagine like if you have some other way to give heuristics to the synthesizer, let's say some other learned model of things or so on, I think that will be fine.
So Sankha, another thing I found from your website here is you used to contribute to Mozilla's Spider Monkey, which is very interesting. And, I know we're running a little bit out of time to dive too deep into this, but, it's basically a JavaScript WebAssembly engine, right? Have you considered applying program synthesis in the WebAssembly space?
Not yet. So back when I was contributing to Firefox, WebAssembly did not exist. So, but when I started getting into program synthesis, WebAssembly did exist, but I did not I was too deep into Ruby to consider WebAssembly. But it would be interesting to think of what kind of interesting problems could synthesis automate away in the WebAssembly space. Because right now WebAssembly is all about compiling, let's say, native code to this target, and which existing compilers are good at, and synthesizers are compilers that don't work really well yet. So
that's fair. So I'm kind of curious, just circling back to your previous experience at BrowserStack, what kind of, from your infrastructure work there, has helped you in exploring, all of this new program synthesis? Like if somebody else wanted to, help join in the effort in program synthesis, what kind of takeaways would help them pursue that a little better?
So I like to think of program synthesis as a tool that can automate the search for programs in some sense. So think about all the situations where, let's say, you had to come up with this tiny piece of code that solved a particular problem. And let's say you had to write that piece of code multiple times for depending on different targets. And those are the things that help. So let's say you have a certain class of problems for which you are writing a heuristic, and then another class of problems for which you are writing another heuristic. And that heuristic is composed of the same set of functions. It's just a different permutation of those things. And these are the situations it helps in. So giving a very concrete example, so this is not really program synthesis, but what happened is, what BrowserStack does is it gives you a set of mobile devices and desktop terminals on which you can run your web browser tests. What that means is, whenever you're asking, let's say, give me an iPhone 6s, it's going into the data center, provisioning a device, like a real physical device, and it's setting up all your user accounts in there and then giving you the access to that and remotely streaming that screen. Now, what happens is there's actually 5 or 6 devices that are connected to a single physical computer, right? And these communication happens over the wire. And if this is happening over the wire, things can wires get loose because it's a physical world. Wires are loose, things go wrong. So you have to add a bunch of retries, real world things. And because of this, this back and forth communication, what happens is things are slow. So your session takes a long time to start. And what we did there is come up, we had an existing bunch of code that was doing this back and forth. So we decided to come up with another tool that sort of goes through this entire thing, comes up with this one script, sort of evaluating the existing scripts, comes up with this one script with all the dependencies, combines that into a big tar gzip wall, sends that over the network, and then that's one communication, and then your network is used only once, and then everything is happening over the streaming facility. So things like that could be automated well with program synthesis, although we did not use that there because I did not know about synthesis back then. That's something definitely worth exploring, I guess.
Yeah, that's really interesting. I can see how that definitely applies to the synthesis project. That's pretty cool. Well, so I'm going to ask the question for Luke because it seems he's not going to ask it, but how can we use program synthesis to generate our tests?
So, I mean, I know a couple of people who are looking into it, to be honest, and they are coming up with a bunch of results. So the problem with writing tests is you can test a bunch of things, but only few tests are interesting. So let's say you want to test reverse, you check with 1, 2, 3, it becomes 3 to 1. But then checking with 4, 5, 6 doesn't add any value. A synthesizer could come up with 10,000 tests like that, which do not add any value. So that's the key problem that needs to be solved. Which tests are good tests? If someone has a good insight into that, I mean, that problem, we will make good progress in that problem. But I think people are making good progress there. And it's based on some domains. It's if you have a bunch of if then else cases, it's very easy to know, okay, these are the branches I should test.
Yeah, I'm curious to see what kind of programming changes will come out of this too, right? Behaviorally, because if you make it so that, okay, program synthesis can happen if you just model your way of programming this specific way, right? Where you use less, meta programming maybe, or have things more defined in scope. I don't know. I'm interested to see if this does take off, and second, if it will change, how people program, and that because it's hard to teach an old dog new tricks, right? And so once people know how to do something, it'll be hard to get them out of their patterns, right?
I'm definitely excited to see how this effort shapes up. It will be exciting, how programming sort of is influenced by these sort of developments.
So I'm curious, are there other projects focusing on other languages with program synthesis, and kind of what parallels can be drawn with what you're working on?
So, I mean, there definitely are a bunch of projects. So earlier, like the more well-known research projects, they worked on toy languages because they were like easier to reason about. But one tool that I really like is Rosette, which is like this embedded language in Racket. And Racket is this nice scheme-based language. So you have like nice X expressions. And in Rosette, what you do is you just write an interpreter, and then it does the solving like transparently behind the scenes. And very nice thing about Rosette is it has very good documentation, so anyone can like sit and walk through the documentation and build synthesizers themselves, which is really cool to have. And then maybe someday when I have time, I do want to write documentation like that for RBSyn, but that day has not come yet. I mean, and Rosette has been used to verify and synthesize code for like a bunch of other things. Let's say they sort of model a C-like language in their Racket language, and then what they do is they sort of synthesize policies for sandboxing certain security components and so on. So like bunch of really domain-specific, application-specific things, but it's an interesting tool. And there has been tools in Java as well called SciPet, but I don't know of any publicly available versions for that.
Yeah, this Rosette one is pretty cool. The syntax reminds me a little bit of this Ruby gem called Parselet that I've been using recently. Basically, make your own grammars out of various rules. Well, Sankha, is there anything else you specifically wanted to share with the audience or explore before we move into picks here?
I mean, synthesis is definitely a sort of hot topic in the research community, and it's taking off. So if you want to get your hands on like to explore whatever is happening, I think just Googling around and you'll find like a couple of blog posts that sort of teach you how to make these toy synthesizers to give you a flavor for how these tools work. And I think those help get people excited about what's coming.
Yeah, I'll tell you what, I'm excited to explore more of what you have here. It's all pretty interesting stuff. Luke, is there anything else you wanted to add, or do you want to move right into the picks?
Yeah, I'd just like to say that this program synthesis thing seems to be a very broad field. On the one end, you've got this flash fill thing, which works in under a second, and basically gets the name out of an email address. But on the other end, you've got these kind of massive projects by Intel, which run for kind of days and weeks, generating incredibly finely tuned floating point algorithms, to kind of get that extra 0.1% at a CPU level. So it is a very, very broad field. And I like how this kind of fits in the middle of those, where it kind of takes about 20 to 50 seconds. And I think it looks like a really kind of genuinely new thing that you can do with these tools.
Yeah, I mean, so if you like the examples that you gave, right? Flash fill, which is meant for end users, versus something like the Intel's floating point libraries routines, which are like programmer who's writing that are like really, really expert in that particular niche topic. And as the expertise level changes, the running time for the tools also change. And I think we sort of need to come up with, and this is something that a lot of us are working on, is how do we explore this entire spectrum of, let's say, less than a second tools to, let's say, multiple hours to days sort of range? And can we move fluently between, let's say, one end of the spectrum to like something in the middle to all the way to the end? And can we design tools for, let's say RBSyn, for example? It does something to do with database accesses, right? That's somewhere in the middle. So the time investment also changes accordingly. And it's an interesting question to see what general sort of structure allows us to like move us along the spectrum in both those ends.
Well, I think we've covered quite a lot here. I mean, there's so many more things we could talk about with where it's leading, right? Because it seems like there are just so many possibilities, so many different applications once things are smoothed over. So what's kind of your biggest next challenge specifically with RBSyn? Are you planning to continue building it and expanding the test cases or benchmarks, or are you planning to transition away to something else?
So the project that I'm working on now, it takes sort of makes RBSyn more general, although it's not targeted to Ruby anymore, because I want to show the generality of the tool. But what it does is something like if you want, you can use types. If you want, you can use something like, as I mentioned before, string lengths. Or if you want, you can say, let's say you are working over data frames of pandas, and you can say my data frame will have these column names, and like whatever kind of hints you provide, it should be able to use those hints and then guide the reasoning of the program with those hints directly. And the idea is to sort of see, can I make those can the tool work over any sort of hints that I can provide it, instead of just limiting itself to, let's say, the types or the effects that we did in RBC.
Oh, that'll be great. Kind of like an annotation system.
Yeah.
Overlapping it.
Yeah.
I can see how that would be very helpful.
So like strings could become, you could say string starts with some, let's say, foo, or the string ends with XYZ, or let's say the string length will always be between 3 and 6. And so these sort of hints will like guide the search.
Oh, that's cool. So if we want to follow along with your progress, where's the best place to follow along?
I mean, I will definitely tweet out whenever I've made progress. So the Twitter is the best place to follow me. I also occasionally post whatever the progress is on the website, but it's definitely less real time than Twitter.
Gotcha.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. You know, whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
So I'll pick something that we find interesting. Doesn't have to be programming related. So Luke, why don't you kick it off?
I'd just like to say that the RBSyn GitHub project, I can see you're using the issues to kind of track planned work in progress. I really like that because it kind of gives a really good idea of where the project's headed. My first pick this week is a bit of a naughty pick, and it's a thing called a zip bomb. So a zip bomb is a zip file that is maybe only a couple of kilobytes big, but it decompresses to several gigabytes. And the link on the bamsoftware.com page contains not only examples of fun zip files you can upload to unsuspecting servers, but it also discusses how they work and the various different possibilities depending on which zip formats are provided. And yeah, it's a really good read. My second pick is Sean Heimel's channel on YouTube, and he's been covering a thing called TinyML. TinyML is taking things which are being done on kind of GPUs, big GeForce graphics cards of CUDA processors, and taking that kind of machine learning and putting it on microcontrollers, very kind of non-power computers that have very low power consumptions. And I love all his videos. They're all brilliant. But this series of videos is really interesting for me because it shows you can do things which were previously, unthinkable, like kind of speech recognition on computers with only just a few kilobytes of RAM, and scale up from there. So that's my second pick, is Sean Heimel's current TinyML videos on his YouTube channel.
Awesome. Sankha, why don't you go ahead with picks?
So I would like to give a shout out to this board game that I've been playing recently called Scythe, which is really cool, awesome strategy game where like you build your civilization, you collect resources, build machines, go and attack other civilizations. And this set in post First World War era Europe. Like you have a bunch of civilizations and they have their own strengths and weaknesses. But the best part about Scythe for me is there's nothing random in the game. Everything is deterministic and depends on the decisions that you take, which is why I like it so much.
That sounds really interesting. I think Chuck probably missed out the board game recommendation here.
Right, it's the first time a guest has picked a board game and Chuck's not here.
Well, he'll probably love hearing the recommendation after the show here. So I just have one pick here. I just came across Stripe just released their new Stripe apps, which are just like a way to embed custom UIs in the Stripe dashboard. But more importantly, it's built on top of a tool by Shopify called Remote UI. It's a really cool piece of technology to create custom component APIs in JavaScript. And they render in their own custom background thread to make things more performant and kind of snappy. I'd recommend checking it out. It's really interesting. At least read through how all that works. Pretty exciting stuff. So unless anybody has anything else, Sankha, if you want to just reiterate how people can reach you, how they can get in touch with you after the show.
So I can be reached at Twitter on at NGSANKHA. That's NG Sankha. Also, you can email me at my email ID, which is sankha@cs.umd.edu. It's also up there on my website at sankhs.com.
Awesome. I'm really looking forward to seeing where this synthesis goes. And thank you so much for coming on. And until next time, folks.
Thanks for having me.
Adios.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.